We have been using the word debugging quite a lot through the module so far. So let's understand what debugging really is in a more formal way. To understand debugging, we realize that we look at testing, because testing is the notion of checking whether your code is or your system is doing what it's supposed to do. So there's two kinds of testing we do. One, which we call the idea of black box testing. And the idea of black box testing is we look at our system as if it were a box. That is, we don't know what's inside it, but we know how it's supposed to function. So this is the box we are trying to test, some module that we are trying to test. It's a software module, let's say, module to test, and we subject it to inputs. We know how it's supposed to react, so we know what our expected outputs are. So in black box testing, then, we do not look into the box. The box is in some way it's been obscured. So we don't care about what's inside the box. We simply test its behavior by looking at inputs, by subjecting it to inputs, and by looking at the outputs to see whether the outputs are as expected. As opposed to black box testing, white box testing. Now, usually we perform white box testing when we find that there is some mismatch in the behavior. That is, the expected outputs are not what we see. So we delve deeper into the box. So in white box testing, then, we actually enter the box, if you will, and we open the box and we step through it. So it's usually done through what we call as single step, stepping through the code. So that's white box testing. So the idea then is debugging involves both white box testing and black box testing. The fundamental ideas behind debugging are to have what is called control and observability. So let's see what that means. So by control, I mean that I fix the inputs. If I, let's say, control, so if I fix the inputs to a system and I observe the outputs, so these are my outputs, and this is my system or my module that I'm testing. If I fix the inputs, then any change in the software, so now if I, let's say I change the software, so I modified the software, and this is a module, but a different version of the module. I'm putting it as prime. If I change the module, I expect that the outputs should still be the same. So my expected output should match this. Just because a change in the software doesn't mean that the outputs will change, because the behavior of the system is based on, for a given input, there is an expected output. But what if they don't match? So what if these is not equal? Then we know that since we've controlled the inputs, the culprit is the modified code. So we can point to the modified code. So by doing that, we are able to isolate the error to the modification done in the software. So that's what control is all about. Observability then is the idea of making sure that any changes that we do can be observed. And we do that by capturing the state of the system, that is the changes that we're doing, by using variables. And we'll look at that as with an example. State variables are what we observe to notice that the changes that we did have affected the code in some form. Another aspect of debugging is what we refer to as intrusiveness. Intrusiveness is a measure. It's a measure of the effect that the debugging has on the system that's being debugged. So this measure has a degree associated with it. So we talk about the degree of intrusiveness. This can be highly intrusive on one end of the spectrum, to minimally intrusive, to the other end of the spectrum where it is non-intrusive. So for example, if I use print statements as a mechanism for debugging, that's very intrusive. If I use the mechanism of instrumentation.
What does that mean?
Instrumentation is to collect debugging data. We collect data in arrays. The collection itself takes some time, but it's minimally intrusive. The third end of the spectrum, the other end of the spectrum, is non-intrusive. This could be a logic analyzer, which is a passive observer that does not disrupt the function of the system. Therefore, it is non-intrusive.
But I don't understand. What does this mean quantitatively? How can you give me another definition?
Well, one way to look at it is the relative intrusiveness. For example, print statements operate in the order of around 10 milliseconds. So every time I call a print statement, it incurs a delay of 10 milliseconds. On the other hand, if I were collecting data collection takes on the order of 1 microseconds.
Ooh.
Whereas non-intrusive is 0 interference. Now let's try and see how this matters from the collection of data or the debugging of the system itself. So imagine I have a task that needs to be debugged, and the task takes 20 milliseconds. Now, if the task takes 20 milliseconds and I have, every time I want to debug the task, I have a 10 millisecond overhead for debugging it, that's 1/3 of the time of the task. That's a lot of interference. Now imagine here we have the same 20 millisecond task, but I have a small amount of data that I gather, which is my 1 microsecond. And this intrusion is very minimal in terms of the function of the system. Whereas here, the 20 millisecond has no interference whatsoever.
Oh, now I understand.